So I'm trying to record this because I don't know for how many days this type of classes will continue, because people have lost patience to listen, and whenever you need, you may learn. If you are interested, you may learn. So that is the order of the day today. So I feel we will not actually continue this type of classes in the coming semesters, I don't know. So in this view, I am trying to record whatever I teach. So there are some basic concepts to be understood before we actually go into a big equation. So please write relate linear acceleration to angular acceleration. Relate linear acceleration to angular acceleration. So here is a wheel, and this wheel, of course, here we are trying to calculate acceleration. Acceleration is finally from the wheel. So if you know the acceleration of the wheel, this is the acceleration of the vehicle. So linear acceleration refers to suppose the wheel is rotating like this, then the wheel will have an angular acceleration. People call it as AX because in the SI convention, X refers to forward direction, forward positive directions. Okay, A refers to linear acceleration. What is the notation for angular acceleration, guys? Now, what is the notation for angular acceleration? Alpha. Okay, so we want to relate between A and alpha. Okay, I think long back in kinematics of machines, you might have actually seen something like this. Okay, it's a link which is actually hinged at a point, and if you wanted the velocity of this point at a distance r from the center of rotation, this is the distance r, and the instantaneous velocity at this point v would be equal to, what is the formula? R omega. So that means it is the product of radius multiplied by angular velocity. Of course, this angular velocity has to be in radians per second. And if you substitute this r in meters, you get this in velocity in meter per second. If you substitute this in mm, then you get this millimeter per second. Okay, so we know this equation v is equal to r omega. We again use the same equation, v is equal to r omega, where v is the linear acceleration of this point. Okay, so v is equal to r omega, and here before this acceleration, let us also consider there is an angular velocity. There is an angular velocity, and if this is again like a link. This is again like a link. If it is rotating at an angular velocity omega, then it will have an angular velocity v either here or here. You can call it as Vx because it is in the forward direction. So the same velocity is at the bottom here. Okay, that's again v. So both are equal. So that means now whatever how much ever this wheel moves backward this way, and the center of the wheel goes forward this way. So you can say that this Vx is nothing but r omega. So Vx, basically the velocity of the wheel is given by r omega. So what we'll do is, we'll divide both the sides by t. We know v by t is acceleration, r by omega by t. Basically, this is actually we are speaking in terms of change in velocity divided by time and change in angular velocity divided by time. So, can you tell me what would be the equation? Change in velocity divided by time is equal to acceleration, and change in angular velocity with respect to time. How fast the angular velocity of a body changes. So that is called as angular acceleration. So this becomes angular acceleration. If the unit for this was radians per second, since you are dividing it by one more second, the angular velocity unit will be radians per second square. sorry, the angular acceleration will be radians per second square. So this is r alpha. So in this way you are able to relate the linear acceleration of a wheel with respect to angular acceleration of a wheel. Okay, now to actually confirm whether you understood this formula or not, let us take a simple example. Let us say that at a time t is equal to 0, the wheel is stagnant, so that means there is no velocity. There is no velocity, so acceleration is also 0 and angular acceleration is also 0. Okay, at time is equal to say 2 seconds, this velocity, this acceleration, I will directly write it as, okay, instead of 2 I will make it as 1 because that makes the problem easier. We don't want to complicate with numbers, we just want to know the procedure, that's it. After 1 second, that's at 0 second, we have this, let us forget about this velocity. And now, okay, even if you want to measure this velocity, it's okay, v is equal to 0. And after 1 second, let the velocity of this body be v is equal to 5 meters per second. 5 meters per second. Can you calculate what would be the value of a, what would be the value of alpha? This is simple physics. Yeah. Calculate the value of acceleration. Calculate the value of angular acceleration. This is very simple. So what is acceleration, guys, here? If I want to find this acceleration, what is acceleration? Velocity. So change in velocity. So with respect to this 0 to 1 second, the change in time is 1 second. And change in velocity is 5 meters per second. So this acceleration becomes 5 meters per second square. It changes the speed of 5 meters per second for every 1 second. Okay. And then angular acceleration alpha. So that can be found out by the formula R. So A by R. So you can write this as A by R. So if you know A, that is 5 meters per second square divided by R. So here, let us actually consider an easy value like 0.1 meter. Let us consider with this wheel has to be 0.1 meter to make our problem easier. Or otherwise you can make it as 0.5. Okay, 0.5 meter. So because it makes a calculation easier. So you can say that 0.5 meter, this goes by 10. So this is radius. This is radius. So how many times you are dividing the radius? That becomes 10 radius. Okay, because what you are dividing is what? Radius. So how many times radians? It is actually 10 radians per second square because you are dividing it by radius. So what you have finally is actually 10 radians per second square. So in this way you are able to relate linear acceleration to angular acceleration.